Greetings and welcome to my presentation that is based on the application of machine learning in real life settings. My name is Innocent Bayai, an aspiring data analyst under training with Career Foundry, and I'm going to walk you through the new strategy for ClimateWins, which is a small European NGO uh, concerned with predicting weather variations, making use of machine learning methods. Now, in line with the interests of ClimateWins, this project seeks to have a way of uh, using machine learning to predict uh, climate change in Europe and potentially even the world. The implication here being that there is need of understanding the unusual weather patterns that are linked to climate change in Europe, and also the frequency of those unusual weather patterns that are linked to climate change. Then this project also seeks to have a way of projecting future weather changes in the next 25 to 50 years so that people get prepared right now of the likely change that are going to happen in the future. By so doing, it is possible to also match those places that seem to be having uh, less of catastrophic maybe climate change disasters, which are deemed to be safe, so that we understand which places are likely to be safe, and then people can be moved to those places that are likely to be safe as climate change worsens. Now, based on the objectives of the project that I presented already on, the three key thought experiments that are related to this project are as follows. Number one, there is need of identifying and classifying unusual weather conditions, and these are likely to affect humans, of course. But the the machine learning approaches that are likely to be used that I've already tried and worked on already. Number one, they include the convolutional neural networks, the CNN, and the recurrent neural networks, that's the RNN, and the random forest models. Um, they the nitty-gritty and the details of these methods are going to be presented in the next slides. Then the other thought experiment that is being worked on, it is projecting future weather conditions in Europe. And here, the approach of machine learning is more aligned to generative adversarial networks, the GANs. And also number three, uh, identifying safe places. They could be towns or weather stations that are being studied in the face of extreme climate change. But these, of course, are going to be identified, making use of the results from the generative adversarial networks. Both these are going to show us the places that are going to be having normal weather conditions, and those are going to be labeled as safe places, safe towns, safe stations, something like that. Then with this now, we need to be looking at the preliminary results that are coming out of the CNN, the RNN, the random forest, with respect to identification of unusual weather conditions, the projection of future weather conditions, and the identification of safe places. So the CNN is a very important machine learning method here, as it can read weather-related satellite images and also high dimensional data. And this model, you can optimize it and attain very high accuracy levels. So rightfully after employing this model, the accuracy after optimizing was around 98.62%, indicating a close to accurate prediction of weather. And by looking at the confusion matrix, uh, the the better of the predictions are correct, implying that this is an almost perfect model. Then when it comes to model accuracy, um, the percentage, which is 98.62%, shows that this is a better model for weather prediction. And the model loss also shows that this model is having less of the losses, implying that this is a good model for predicting weather conditions going forward. Then we also have the random forests. These are very important because they are good at avoiding overfitting, and they can be used to forecast current weather conditions through the interaction of multiple weather features like humidity, temperatures, sunshine, cloud cover, and all that. Now, how does it work? It runs several decision trees at the same time, and then combine prediction to get an averaged out weather condition at any given time. So this is very important. But what is it that has come out of the models that we have run already? So what we are having here is that the accuracy of this model climaxed at 66%, which is not very good. But what is most important coming out of this model is that those stations that are most important, they were identified as Düsseldorf, Oslo, and Basel. And also the weather elements that are also very important from the top three stations. They were the temperatures, um, precipitation, and average temperature gain. So now what it implies is this model can identify those weather elements that are very important in defining the weather conditions at any given stage. And this model remains important in getting uh, uh, the weather conditions that are obtaining at each individual weather station at any given time. Then we also have the recurrent neural networks. This approach can be used to predict weather conditions, making use of a time series of a past record of weather data like temperatures, precipitation, as long as it is past data, making it a sequential prediction model. But the problem that we are having now is its accuracy was around 62%, which is not very good. And the confusion matrix that we ended up having, it also missed the 1 out of the 15 weather stations that were being studied. So there's need of optimizing this one for a better prediction capacity of this model. Then we also look at the generative adversarial networks here that we're having. This is very important when it comes to ClimateWins' interest in trying to project future weather conditions going forward. So this model can project future weather conditions through two different neural networks, the generator and the discriminator, working against each other. So there's possibility of coming up with synthetic weather data which can be trained, and making use of that, we can make predictions by either using CNN or RNN. So the merits that we're having out of this GAN is that it is possible to identify safe locations in advance, because we have generated synthetic weather data which we can now simulate, and making use of those simulations, we can predict which places are going to be safe and which ones are not going to be safe. But for us to be able to do all this, there's need of additional data outside the normal historical weather data that we are having here. For example, we might need high resolution satellite weather images that we can use for ECNN. Then we also want a current weather data, a real weather data that is to be used to update models that we are running already. Then since we also want to look at the global weather forecast, then there's also need of collecting ground-based weather station data from multiple locations across the globe. Then lastly, there's need of looking at other global atmospheric data models such as the numerical weather prediction models, and these ones are linked to the jet stream, pressure systems, and climate oscillations such as El Nino and La Nina. Those are some of the data issues that are required here. Recommendations now require that ClimateWins must collect data across the globe if it is going to be able to predict weather conditions across the world. And number two, there's also a need of coming up with high resolution satellite data for us to optimize our forecasting using the CNN. And this one is good because it can achieve high accuracy levels once we have the rightful type of data that we are inputting. Then when it comes to the use of predicting future weather, there is need of developing that model from the GAN, and making sure that we optimize it and be able to come up with a very efficient predictive model that can give us forecast into the future based on a synthetic weather and data that we are generating. I thank you, and here's my email, my GitHub link, and also the YouTube link that I've created for this presentation. I thank you.